Good morning. So I'm recording this message on this windy and crazy weather day that we're having. So if you hear some rattling in the background, it's probably my windows from all of the wind. Well, hopefully at this point you have completed your moon research. We started it on Thursday, and yesterday there was a follow-up assignment. So what I wanted to do before giving you today's assignment, which I think you're really going to enjoy, I decided to kind of do a wrap up of the research, going over the answers to those research questions. Even though I've been giving you feedback and having some of you go and do some further research, I think it's important to do this wrap up. So, the first thing we're going to talk about are the surface features of the moon, because that was the first thing I had you research. So, one of the surface features we find on the moon are called marias. Now, Marias is a Latin word for ancient seas. And the reason this surface feature is called a Maria is because when scientists were originally observing these features through telescopes, they thought they were the presence of running water. Well, upon more careful observation, they realized that they're actually flat plains on the surface of the moon, and that these plains were formed from ancient volcanic activity. It's important to know that there's no longer any volcanoes erupting on the moon. The moon is geologically dead, and the reason for that is the core of the moon is frozen. So if a planet or moon has a frozen core, there's no movement within that core, which means there can be no tectonic activity like volcanic eruptions. But this tells us in the past that the moon must have once had a molten core or liquid-like core, allowing for volcanic activity. And when it cooled and hardened over billions of years ago, we got these huge flat plains on the surface of the moon. If you look up at the moon at the nighttime, and you see those dark areas on the moon, what you're actually looking at are the Marias. So next time it's a nice night, go outside, look up, and those dark patches are those ancient volcanic plains. The second surface feature were craters. Now, craters are heavily represented on the moon. Craters are large, round pits or holes on the surface of the moon, and they could have been from ancient volcanic activity and eruptions causing the holes. But more likely now, today, they are formed from the impact of space debris, asteroids and meteoroids hitting the surface. Something cool about these features is on Earth, if space debris hits our planet and creates a crater, over time evidence of that crater will start to disappear because of weathering and erosion. While on the moon there is no weathering and erosion. So any mark from a crater or footprint left from an astronaut remains on the moon today because the moon is said to be frozen in time. Without the forces of weathering and erosion, there are no changes on the moon. Now, of course, if something hit that same spot, another asteroid or meteoroid, it would change it. But there are no natural forces working to change the surface of the moon. The last feature of the moon that some of us had some trouble finding were the highlands. A lot of you described the type of rock that made up the highlands, which shows some evidence that that rock was volcanic in nature. But highlands are mountains on the moon's surface, lunar mountains, which are why they're called high lands. These appear as the light features on the surface of the moon. Because they're higher up than the Marias, the light reflects off of them, allowing them to appear light. So when you go outside to check out the Marias, also look at the light parts of the moon. Those are the lunar highlands. These highlands more than likely were formed by impact lifting up the surface. Again, it's geologically dead, so unlike Earth, where mountains are formed from tectonic plate movement, that's not happening inside of the moon. So that's not what is causing the uplift. As things hit the surface of the moon, that causes the surface to uplift. A feature I didn't have you look up was called regolith. And regolith describes the dusty surface of the moon. It's kind of like a powder, like a light powdery surface. And when you watch today's video, you'll hear the astronauts discuss the regolith, or that dusty surface of the moon. I also had you look up the presence of water. So water does exist in the moon, but not in liquid form. It exists frozen in two spots, and actually there's evidence of possibly a third. So it exists frozen deep inside craters, as well as at the poles, because both of these locations are shielded from the sun. So in the daytime, it wouldn't melt. There is some new evidence that suggests there may be some area of permafrost or frozen water underneath the lunar soil. There have also been small, tiny traces found as gas in the gases that kind of float above the surface of the moon. But you're not going to find it in liquid form, and you're not going to find a significant amount above the surface. Then the second day, I had you look at the temperatures, and there's an extreme difference between night and day. So during the daytime, the moon's surface temperature, and I have it here in Celsius, so excuse me while I look, was 130 degrees Celsius, where at night it's 180 degrees Celsius. So that's approximately like 200 degrees during the day Fahrenheit and negative 270 degrees Fahrenheit at night. And the reason it's so boiling hot during the day is because the moon doesn't have an atmosphere. And without an atmosphere, all of the sun can beat down on it. Our atmosphere helps control the amount of sun that actually is absorbed into our surface and reaches our surface, but the moon doesn't have that. Then at nighttime, all of the heat that was beating down on the moon escapes out into space. There's no atmosphere to trap it in. So the reason why our temperatures don't get cold to the point where we can't survive on Earth is because our atmosphere stores some of the heat from during the day. The moon doesn't have that. So you have these extreme day and nighttime temperatures. And since I mentioned that the moon doesn't have an atmosphere, I think it's important to mention why. During your research, you might have found some small amounts of gases that they say float above the surface, but the moon is so small, it doesn't have enough gravity to hold on to an atmosphere and maintain one. And even if it did, the sun's solar winds would probably rip it off. The moon's weak gravity, also known as microgravity, a lot of you were asking me about this yesterday, is because the moon is so small. Remember, and we investigated this last week, as mass decreases, gravity decreases. So the smaller the object, the weaker the gravity. Now keep in mind, the moon does still have gravity, because if not, astronauts would not be able to visit there. They would float right off the surface. But when you watch footage today of the first moon landing, you'll see the astronauts testing that microgravity and jumping higher and bouncing around the moon. They have that feeling of weightlessness, because the moon's gravity is about 1/6 of what it is on Earth. So in other words, if you took your weight and divided it by 6, that's how much you'd weigh on the moon. And I think we calculated that earlier last week as well. So that's what microgravity means, weak gravity. So if an astronaut was walking along the moon and an asteroid came and impacted him, it could blow him right off the surface. But because there is some gravity, he can actually step out and explore the moon and not float away. One thing I didn't have you research, but I think it's important to mention it, because a lot of you talked about the magnetic field. A magnetic field is what protects a planet from solar radiation. Evidence of a magnetic field are those beautiful light shows known as the aurora borealis that can be seen in places like Iceland. And the aurora borealis is the effect of our magnetic field protecting us from incoming solar storms and large amounts of solar radiation. The moon does not have a magnetic field, and the reason it doesn't is because the core is frozen. It's the movement or the rotation of a molten core that creates a planet's magnetic field. So since it's frozen, it doesn't have one. So there's no protection from that solar radiation, which is something they have to consider in the design of spacesuits when they send astronauts to the moon. Which leads us to today's assignment. So after watching my video wrap-up, you're going to watch a video from CBS News. It was the 50th anniversary special of the first moon landing. And it's going to introduce you to the 3 astronauts that were involved in that moon landing, talk about some of the challenges that they faced, some of the planning that had to take place before this huge mission to the moon, and also some of the things they did while on the surface of the moon. So you're going to be introduced to 3 astronauts, Buzz Aldrin and Neil Armstrong. Those 2 gentlemen were the 2 gentlemen that actually walked on the surface of the moon, the very first 2. Then you're also going to be introduced to Michael Collins. Michael Collins, unfortunately, is sometimes left out of the big discussion of the first moon landing, and he shouldn't. And the reason why he's often left out is because he did not get a chance to walk on the moon. It was Michael Collins' job to stay orbiting or revolving around the moon while his two fellow astronauts explored the surface. So he was the commander, he was the pilot of the mission. So I think you're going to enjoy this video. It's an important historical moment for not only Americans, but for around the world, and you'll see that. So when you're done watching the video, both videos, my video and that one, please make sure you hit the turn in button. And I also encourage you to do further research about the moon landing if you are interested in it, and also see the missions leading up to the first men on the moon, and maybe the missions following, because those two astronauts were not the only two to step on the surface. And there's a lot of talk of bringing back the Apollo program, and the Apollo program is the program with missions to the moon. So it might be worth a little research if you're interested. Who knows, maybe you'll be on the surface of the moon one day. Have a great day. Bye.